Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today. Reverse string, Leetcode 344. In this problem, we are given input string as array of characters and we should reverse a string in place, that is with O1 extra memory. Then in example 1, for the given string hello, our output will be ole, which we will get by traversing on the string characters from right to left. So first we will get O, then L, then E and then H. In this problem, we are given a mutable char array, so we can do the reversal in place. However, if we use a default string implementation in different programming languages, this is not possible as strings are immutable. I have already covered the immutability of strings in Java. If you are interested, please check out the I button. Also, the naive approach would have been to just create a new array and store the characters by traversing the string from right to left and then put those characters back into the original string. But we are not allowed to use extra space and we have to also do it in place. So one way to achieve this can be to think of reversal as a swap of characters. That is, we swap the first character with the last one, then the second character with the second last one, and so on. So we can use two-pointer technique to reverse a string. Left pointer starts at the beginning of the string and right pointer starts from the end of the string. Now we can swap the elements at the left and right pointers and move the left pointer one step to the right and right pointer one step to the left. And we will repeat the swapping process until left pointer meets the right pointer. And this solution will work regardless of the case whether the string is odd or even. Let's see this with an example. So initially left is at 0 and right is at index 4. So we swap the element at 0th and 4th index. So now our string becomes O, E, L, L, H. And once we perform a swap, we will move the left pointer forward and right pointer backward. Now we again swap the elements E and L. So now our array becomes O, L, L, E, H. And once we have performed the swap, we will again move left pointer forward and right pointer backward. And now both left and right pointers point to character L. So now we can either swap the values, which is unnecessary because L stays in the same position in the end. So we can stop the iteration here itself, or we can stop the iteration when L and R crosses each other. So it's up to you, but in both the cases our array is now reversed. And this was a string with the odd number of characters. Now let's take the string with even number of characters. For example, string hello with 1L. Initially left points to index 0 and right points to index 3. So we swap the characters at 0th and 3rd position. So our string becomes O, E, L, H. And after the swap, we will move both left and right pointers towards the center. Now we again swap these two characters. So now our string becomes O, L, E, H. And we will again increment the value of L. So our L comes here and decrement the value of R. So our R comes here. And now since left is greater than right, we will stop the iteration. And our array is now reversed. Now in terms of time complexity, as we were going through all the characters only once, the time complexity will be O of n, where n is length of the string. And in terms of space complexity, since we are doing it in place, it will be O of 1. Now let's code it up. First, let's initialize two pointers, left and right. Left points to the beginning of the array and right at the end. Now we will start the iteration. While left is less than right, that is, we still have characters to swap. We will swap the characters at left and right pointers using a temporary variable. So first we will store the value of character at index left in a temporary variable temp. Then we will assign the character at right index to the position of left index and assign the temporary value to the position at right index. This completes the swap. So we will increment the left counter towards the center of the string and decrement the right counter again towards the center of the string. And once we are done with the iteration, our string should be reversed. So we will return. Now let's submit this code. Cool. Another approach is a variant of two-pointer technique. In this approach, we loop through the string from start to the middle of the string using the iterator say I, and then we can swap the ith character from the start with the ith element from the end, which will be at position n-1 minus I. For example, we will swap first and last character, second and second last character, and so on. The time and space complexity of this solution is similar to two-pointer approach. So, time complexity of this approach is O of n because we iterate through half the array, and space complexity is O of 1 for performing in-place traversal. I will skip the code for this one, but if you are interested, please check out the link in the description below. And now, if the interviewer is fine with using extra space, then we can solve it in many more ways. One way can be recursion, where again we can take two pointers, left and right. The left pointer starts at the beginning of the array and right pointer starts at the end of the array. And now we can swap the values at left and right pointers and increment the value of L and decrement the value of right and make another recursion call with the new left and right positions. And we will continue this process until the left pointer meets or exceeds the right pointer. And the time complexity of this approach will be again O of n because we process two elements at a time. But the space complexity will be O of n as well because we are using the recursion stack. So now let's jump into this code as well. As we have to use recursion with two pointers left and right, let's write the helper function and move all that code there. So we pass in input character array s and initial left pointer which is at the beginning of the string and right pointer which is at the end of the string. Now let's define the helper function. Note that we are returning void here, similar to original function because we are reversing the string in place. Now we can copy paste the old code here. And first let's write the base condition, and that will be if left is greater than equal to right. That means all the characters have been swapped. So we will return and stop the recursion. Otherwise we will perform the swap. So now we can get rid of this loop. And after swapping the characters, like we were doing in the two-pointer technique, we will call the helper function recursively and pass in the character array s, left pointer incremented by 1 and right pointer decremented by 1. So this way both the pointers continue the process of swapping the characters and move towards the center of the array. Now let's submit this code. Cool. And finally, let's look at the solution using the stack as well, because what can be done with recursion can also be achieved using stack. The stack data structure follows a last in first out principle, which can help us reverse a string by pushing the characters onto the stack and then popping them off in the reverse order. So this ensures the last character added to the stack comes out first, resulting in the reverse order. For example, for the given string hello, first we will push H, then we will push E, then we will push L, then we will push L again, and finally we will push O. And now we have pushed all the elements on the stack, so we can start popping them out. So first we pop out O and set it at the 0th position in the string. Then we pop out L and set it at the first position in the string. Then we again pop out L and set it at the second position in the string. And then we pop out E and set it at index 3. And finally we pop out H and set it at index 4. And now our stack is empty and we get the reverse string as Ole. And the time complexity of this approach will also be O of n as we push n characters to the stack and then pop them off. And the space complexity will also be O of n as we are using stack to store all the characters. And now let's jump into the code for this approach as well. First, let's create the stack to store the characters of the string. Now we will iterate through each character in the string and push it onto the stack. And once we have pushed all the elements on the stack, we will start popping them out. So for that, we will iterate through the indices of the input string s from 0 to last index and assign the popped character at the ith index. And due to last in first out or LIFO assignment of the characters, the string gets reversed. So we should return. And now let's submit this code. Cool. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.